Greetings, everyone. This is Jeff Wilkerson, professor of physics at Luther College, bringing you the next in our series of what to look for in the night sky. It's January 1, 2024. That's right, we've made it to 2024 for this round of looking up in the night sky. Three things we're going to focus on this week. Three things. We're going to start with something I think we probably do every time this year because I love it. It's one of my favorite things to think about, one of my favorite things to talk about. And so I'm the one here, so we do what I want to do. And so that is on the evening of January 2nd, somewhere I think near 6:40 p.m. for me, Central Time, 7:40 Eastern Time, 6:38 to 6:39, probably somewhere between there it is. We are at our closest approach to the sun. We have very, very tiny eccentricity of orbit. The orbits of the planets are typically pretty close to circular, and how squished they are, that's a technical term, squished, is the eccentricity of the orbit, how much they're elliptical. And the Earth is just about, I think the Earth is the least of all of the planets. That eccentricity is about 1.3%. And so it's really hard. You look at it, you can't tell that it's not a circle to look at it by your eye. You have to measure pretty carefully. And yet, we do get closer to the sun and further away from the sun a little bit. And we are at closest approach on the evening of January 2nd. And so this, what this means, the way we detect this the most is to say when we're closer to the sun, we're actually moving faster in orbit. We're just a tiny little bit closer, so we're just moving a tiny little bit faster in orbit. So there's the sun, and there's the Earth. You can tell it's the Earth because there's a big E stamped on it, okay? And if we build a monument to the sun when it's directly overhead, this arrow pointed at the sun, all is great. In one rotation, we spin one time on our axis, we've moved just a little bit in orbit, and that monument is not pointed directly at the sun anymore. We have to rotate just a little bit more to get the sun back directly overhead. And that time it takes us to rotate that little bit more is about 4 minutes. Okay, this is why the sun, we base our clock on the sun, and so the stars, which are way out there, they can't tell we've moved. We moved that little tiny bit there. All right, okay, you moved. And so the stars get back to the same spot in the sky in one rotation, but that's 4 minutes earlier each night. That's why the stars rise 4 minutes earlier each night for us. Fun stuff, right? But here's the thing. When we're closer to the sun, we're moving a little further in orbit in one rotation. We're going faster. So we've got a little bit further. We have to over-rotate just a little bit more. It takes longer for the sun to get back in the sky to the same spot. So that means, since it takes longer than average, that means that our clocks based on the sun, things like sunrise and sunset come a little bit later than we would expect otherwise. So the fun part of that is it's now, by the time we get through this week, it'll have been a full month since we had our earliest sunset. And the sunsets have been coming later and later, later and later and later. We've been actually gaining daylight in the evening now for a full month by the time the end of the upcoming week. But we've been losing daylight in the morning. And we've been losing daylight in the morning up until we had solstice. We were losing daylight in the morning faster than we were gaining it in the evening. But sunrise was coming later, sunset was coming later, and now it's going to turn over. Now that we're past this point, it's going to turn over, and in fact, we're going to start the week. By the time we get to the end of the week, the sunrises will be coming earlier too. So we'll be gaining daylight on both ends. Now, what you can do observationally this week to watch this is to say, if you pay very careful attention and you have good daylight in the evening, it's not so cloudy you can't tell how bright it is. If you have good daylight in the evening, you can probably tell that by the end of the upcoming week, by the 8th of January, compared to the 1st of January, you will see that the sunset is getting later. But you got to pay pretty close attention. Now, by another week later, and certainly by a week after that, you don't have to be paying very close attention at all. You'll look up one day and you'll say, oh my goodness, it's daylight later than it's been. And it was all for my Northern Hemisphere colleagues. This goes the opposite way in the Southern Hemisphere. But here where I am in the middle of the United States, every January, I know this happens and I watch this and I pay attention to it And still, I managed to be surprised. It's the beauty of the world, or the beauty of the softness of my mind. I don't know what. But by mid-January, I still am surprised by how light it is in the evening. And we can see that. You watch it in the morning, and you won't notice any difference. It's going to be just about as dark. It's sun's going to come up just about, it's going to start getting light just about the same time at the end of the week as it is in the beginning of the week. And we're at the bottom of what's a sine-like curve, so it's really changing slowly. So even in the next couple of weeks, you're going to have a hard time telling that we're gaining daylight in the morning. But then it's going to start really rolling on both ends. So anyway, it's a great week. Pay attention to how light it is at sunset. Pay attention to how light it is near sunrise, and see if you can notice that difference. See if you can notice over the course of the next week to 2 weeks just how much lighter it is at the same time. Pick 5 o'clock, for example, in the evening. 4:45, 5 o'clock, 5:15, something like that. Watch that and say, oh, look at that. It's staying light a lot later. So that's topic number 1, perihelion passage. Enjoy it. Pay attention to it and appreciate it. Topic number 2, the Quadrant and Meteors. Honestly, I should look this up. I should know this, right? You expect me to know things. Instead, I just act like I know things. I don't know why they're called that. They're meteor showers. We talk about this all the time. They come when we orbit, and the orbit of the Earth runs into debris that's left over by a comet. And we run into that debris, and all the meteors look like they trace back to coming from the same point in the sky, which we call a radiant. And we name it for the meteor shower. We name for the location of the radiant, the constellation in which the radiant resides, which is Boötes in this case. And Boötes, but these are called the Quadrantids. A pretty decent meteor shower usually, not one of the very best, but it wouldn't be unheard of to go out and watch for a while where we're near the peak and see one every 2 or 3 minutes. And so that's a pretty good meteor shower. That's not a bad meteor shower at all if you got dark skies. And this radiant Arcturus. Arcturus is the bright star in Boötes. Remember the handle of the Big Dipper, we like to say arcs to Arcturus, and then it spins on down to Spica. And so you follow the curve of the handle of the bright star Arcturus. This whole region of the sky just clears the horizon for me about midnight. So it means you probably want to be about 1 in the morning for it to be well enough place to be observing. But you can see the meteors before that. The problem we got is the moon's going to be about 50% full. If the moon were 50% full and all the way across the sky, it would be one thing. But the moon's 50% full and pretty close. When you spin on down to Spica from Arcturus, wow, there's the moon. Right there in Virgo and reasonably close. And it's going to wash this out. That said, I expect you can still see a handful of the bigger, brighter meteors. So if you're killing time in the morning, if you're up at 3 o'clock in the morning of the 4th, the night of the 3rd into the morning of the 4th, a.m. in the 4th, it's 3 o'clock in the morning and you got an hour to kill outside, my guess is you're going to see a handful of meteors. But it's not going to be the best it could be because of that moon that's so close. Now, let's talk about the moon then. So we brought up the moon. Let's continue talking about the moon. On the morning of the 5th, 1 day later, the moon will be very near Spica. This moon's pretty near Spica on the 4th. It'll be within 5 degrees of Spica the next morning. So nice moon that's waned away to just below 40% full by that point, and making a nice pairing with the bright star Spica in the morning sky. 3:30 in the morning, 4 o'clock in the morning might be the time to go out and watch that. 3 days later on the morning of the 8th, the night of the 7th into the morning of the 8th, so we still count it in this week because it's the evening of the 7th, but actually in the morning of the 8th, the moon will have waned away to a beautiful, beautiful crescent. The moon will be between 10 and 15% full, but the moon will be right on top of the orange star Antares in Scorpius. It's within 2 degrees of Antares, depending on where you are. It's getting, where you are when it's dark for you to observe this. Best, 6:30 in the morning to 7 a.m. for me, local time, but somewhere probably for you, depending on where you are. That's true, too, your local time. So 6:30 to 7 a.m. is the time to get out and see this beautiful, beautiful crescent moon very near the bright star Antares. The sky might be starting to get bright enough. You have a hard time pulling Antares out of there, and you could want to use binoculars, but I don't think so. I think you'll be able to see Antares and the moon there. And Venus is the big, bright object that's just 5 degrees or so up that direction. So these are really close, really, really close to one another. And 4 or 5 degrees up this direction, 5 or 6 degrees, you've got Venus. And it makes a beautiful, beautiful, beautiful image on the morning of the 8th. So that's what we got for you. We got the moon with Spica and with Venus and Antares late in the week. We got some meteors. Maybe you could see you're going to have a little bit of moon interference. And think about perihelion passage. Think about sunset getting later and later and later, so much so that it's observable now because we're a month past the earliest sunset. And enjoy all of that. And as always, everybody, have a great, great week ahead. And thanks for watching.